Hey, it's great you made it this far. Let's begin adding our new code. First, we will create our attractor, which is a box in Rhino, and we will reference it in Grasshopper. We will want to find the closest points to our box to define the direction at which our vectors will be pointing. And we want to find the distances to use in the magnitude of movement, factor scaling, and degree of rotation. So in order to do that, we will add Brep closest point component, connect the Brep to its Brep input, and the grid points to its points input. Now we have the closest points and the distances outputs. We will then add two more components. A minimum maximum bounds component, which you already know what it does, and the other is a number component, which basically accepts and passes floating point numbers. We will connect the points output of the Brep closest points component to the new point component we created last lecture. Then we connect its distance output to the minimum maximum bounds and also to the number components. Now we want to connect their outputs. So we will connect the minimum maximum bounds output to the three source domain input of the remap components in movement, scaling, and rotation. And we will connect the number component to the value to remap input also in the remap component in the three parts of the code. Now that we are done with this first part, we will move to the vector to points component in the rotation part. We will connect our grid points to point A to define the base points of where our vectors will begin. And we already have point B explained and connected before. Now we can preview our rotate 3D and preview off all the rest of components. And now we have our points transformed according to our Brep attractor. In the coming lecture, we're going to build on this tutorial and I'm going to show you how to use line as an attractor instead of Brep.